To another video on the channel. In today's video we're going to be doing a short response question for 2020 Specialist External Exam Paper 1. Now in this video I'll be going through the work solution to question 11, which is comprised of A, B, C, D and E. If you have any questions at all during the video, please leave something in the comments, that way I can answer it as best as possible. If you need a Specialist External Exam bundle pack, the link is in the description below. There is a discount code that takes 50% off the external exam that you can use at checkout. So if you're interested in that, it will only apply to 10 users, so get in quick. But otherwise, let's still get into this video. Now, if you want the full external exam, the link is still on YouTube. Link is in the description as well below. But let's get straight into it. So question 11. The vertices of a regular hexagon are positioned on the circumference of a unit circle as shown on the Argand diagram. Consider the following complex number W as shown on the plane. Determine W, expressing it in the form RCIS theta. Okay, so first of all, these are all complex numbers. Now, there is exactly 6 of them. Now, the word unit circle means it has a radius of 1. So the distance from here to there, to there, to there, to there, to there, to there is 1. Okay, so that tells me R of W is going to be 1, because they've said represents W with RCIS theta. W can be represented using, that is your R and that is your theta, the distance from the origin as well as the angle of rotation. Now, because there are 6 complex numbers, all of them have to be exactly equal distance apart. So here, that distance and 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 that distance can, because they're all equally distance apart, the entire angle is 2 pi, but there are 6 of them. So each of them will be separated by a distance of 2 pi over 6, aka pi over 3. Now, because we know one of these sections is pi over 3, W is exactly 2 of these sections away from the origin. So this angle here is 2 pi over 3. So here, W, our complex number, is 1 CIS 2 pi over 3, and that's all it is. Okay, now that's only worth 1 mark. However, a lot of people don't get that 1 mark, and if you don't get that 1 mark, you don't have a chance of doing the rest of the questions. Okay, hopefully that's a pretty easy question though for most people. Okay, all right. B, convert to Cartesian form. So if W is CIS 2 pi over 3, we got to remember CIS theta stands for cos theta plus I sine theta. So in this situation here, it's exactly the same thing, except instead of theta, it's 2 pi over 3. Now remember, this is non-calc. So CIS 2 pi over 3 equals cos 2 pi over 3 plus I sine 2 pi over 3. Now you're probably wondering, how do you work out those trig things without a calculator? That's where you need the unit, well, not the unit circle, you need your special triangles. So there are 2 types of triangles you need to know in methods and specialists to answer questions like this. So you've got this one here, your 45 triangle, where that's 1, 1, and that's root 2. I'll write them in radians very shortly as well. You've got your 60, your 30, which is root 3, 2, and 1. So here, we've got to work out roughly where they're positioned as well. Now, it's also good to understand what cast is as well. So here, this represents cos is positive here, sine, cos, and tan is positive here, sine is positive here, and tan is positive here. Now here, we've got to work out what quadrant these guys are in. Now, because they're 2 pi over 3, they're all located in this quadrant here, okay? So cos is going to be negative here. So here, we've got to work out, alright, what's the complement to cos here, okay? So here, we've just got to think, alright, cos of 2 pi over 3 would be negative cos of pi over 3, because that's the opposite thing over here, because that distance would be pi over 3 there, okay? So here, that's the hardest one to work out, okay? If you don't remember how to do that, you'll need to relook at stuff maybe from year 11 actually, okay? Because a lot of this is assumed knowledge. And this one here, sine of 2 pi over 3 is just, because it's still in that quadrant, it's positive sine pi over 3, okay? where I'm getting the pi over 3 from, it adds up to 180. Okay, so let's work out these guys. Now, pi over 3 is 60 degrees. Okay, here I go to this angle here and I think, oh, what is cos of 60? Cos is adjacent and hypotenuse. So cos of 60 has to be a half. Now because that's negative, this turns into negative a half. Okay. Now this one here, because that's sine is opposite over hypotenuse. So that is root 3 over 2. So W in Cartesian form is negative a half plus root 3 over 2I. Okay. Now let's understand if that matches up consistently on the Argand diagram as well. Now if you need any of this working, just rewind the video. Okay. Now here, let's understand what we're actually looking at here. Okay. So negative a half would be the real component. Okay. If we look here, that also matches up quite nicely just here. So all the way there. Okay. And root 3 over 2 is positive, which matches roughly up here as well. So yeah, we're in the right place with this guy here. If you have any questions about any of this, leave something in the comments. But otherwise, let's head on to the next bit. Alright, each vertex of the hexagon is a solution of the form z equals n equals a, where z belongs to a complex number. State the value of n. Okay, so first of all, there are 1, 2, 3, 4, 5, 6 solutions. So this is a solution to the equation z to the power of 6 equals a. Okay. So in this case here, n is equal to 6. I think that's the easiest mark anyone can get on here. So if you didn't get a, you should definitely be able to get c. D, state the value of a. Now a is the original equation. Now the original equation would have been this guy here, because it's a unit circle. So this would be CAS of 0, which would actually just be 1. So this is a solution to the equation z to the power of 6 is equal to 1, because that would give you the 6 solutions. So the value of a in this case here is 1. So that's our equation we're working with roughly, with this guy here. Okay. Now that would have been actually pretty obvious as well from the start. E, verify that W satisfies this equation from 11C and 11D. Okay, so we just worked out W was this. Now, I'm going to bring both formats down here because one is going to be a lot easier to use than the other. Okay, so here, we want to see if it satisfies this equation here. My advice, put it into Cartesian format. Not Cartesian format, polar format. If you put it into Cartesian format, you're going to have to evaluate a power of 6 without a calculator, which is ridiculous. Don't do that, okay? It'll waste too much time. Put everything in polar form. So 1 in complex polar form would be CAS 0. W is already this, so we can just shove W for Z here. So CAS 2 pi over 3, all the power of 6. Now we can use the Moivre's theorem, which means you can apply that power to the thing there. So it's going to be 1 to the power of 6. And you can multiply the 6 by the angle here. So it's CAS 2 pi over 3 times by 6. This equals CAS 0. Now we've got to check if they're equal. Okay. So 1 is 1 to the power of 6 is just 1. CIS, oh, there's no equal sign there. CAS 2 pi over 3 times by 6. The 3 and the 6 are going to cancel to turn to 2. So this turns into 4 pi. Now, these should be equal to one another, okay? Because if we were to look at the sine curve and the cos curve for both of them, okay? Well, we don't have to, but if you're not sure, they can help very much. So here if I draw the cos curve properly. So the cos curve looks something like this. This is 2 pi. And this is 4 pi, okay? On the sine curve, this is 4 pi. So here, this can be written as cos 4 pi plus I sine 4 pi. Now this has to be equal to 1 because CIS of 0 is 1. Cos of 4 pi from the equation we can see is equal to 1. So that's 1. Sine of 4 pi is equal to 0. So that cancels out. So you get 1 is equal to 1. So yes, it verifies this equation here. Alrighty. Is this a hard question to start off with? Yes and no. If you don't know your trig and you don't know your complex numbers, definitely. But if you do, it should be a pretty simple question. It's an easy 7 marks to get. Okay. If you have questions about this one here, you need to study complex numbers a little bit more. If you have a question of your own, submit it in my forum below and I will send you the solution to it or make a video on it. If you need the Specialist External Exam Bundle Pack, the link is in the description below. Use the code at checkout to get 50% off. It'll only work for the first 10 users. So if you're one of the first people watching this video, go use it, okay? But otherwise, I will see you in the next video.